Now let us begin binary trees and its. What is binary tree? A binary tree means that the nodes can have maximum two children. Here you can see there are two children for 1 and for 2 there is two children, that is 5 and 6. Here binary name itself suggests what 2, therefore each node can have either 0, 1 or 2 children. For 3 it is doesn't have any children, therefore it is 0 children. For similarly 5 and 6. Let us understand the binary tree through an example. Observe this diagram carefully. In the above tree, it contains at most two children. The logical representation of the above tree is given below. This is logical means I am taking a node. The node is splitted into a three parts. This is L link, then info and R link. This L link is always connected to the left part of its subtree, and R link is always connected to the right part of its right subtree. One is nothing but information that should be stored in the node. Here you can observe this one of the L link is connected to the 2 and one of the R link is connected to the 3. Then here 2 is there. Here 2 of the L link is connected to the 5 and 2 of the R link is connected to the 6. But here 3 we have put into for 6 here into and here also into. This into represents a null value. That means it does not contains any children's or it is not further grown. In the above tree, node 1 contains two pointers, that is left and right pointers of the left and right nodes respectively. The node 2, here you can see, contains both nodes, that is left and right. Therefore, it has two pointers. You can see the node 3 here 5 and 6 are the leaf nodes. So all these nodes contains null pointers on both left and right part. What are the properties of the binary trees? At each level of I, the maximum number of node is 2i. Here you can see when I put I equals to 0, 2 to the power of 0 plus 2 to the power of 1 plus 2 to the power of 2 plus 2 to the power of I. If I evaluate this one, 2 to the power of 0 is what? 1 plus 2 to the power of 1 is 2, 2 to the power of 2 is 4 and so on. Then now let us concentrate on the height of the tree. The height of the tree is defined as the longest path from the root node to the leaf node. That is in the above previous example from 1 to 5. And the tree which is shown in the above has the height equal to the 3. Therefore, the maximum nodes of the node at the height 3 is equal to, first one is root node, therefore 1. Next it is having two children nodes, that is 2, and next 4. Similarly 8. When I make this sum, we will get 15. In general, the maximum number of nodes possible at height h is 2 to the power of 0 plus 2 to the power of 1 plus 2 to the power of 2 plus 2 to the power of h, that equals to the 2 to the power of h plus 1 minus 1. This is the height. Then the minimum number of nodes possible at the height h is equal to the h plus 1. That means if I put h is equal to 0, the maximum height is 1. Sorry, minimum height is 1. If the number of nodes is minimum, then the height of the tree could be the maximum. Conversely, if the numbers of nodes is maximum, then the height of the tree could be the minimum. Here you can see if there are n numbers nodes in the binary tree, the minimum height can be computed as follows: n equals to 2 to the power of h plus 1 minus 1 and n plus 1 equals to 2 to the power of h plus 1. I will take the log on both sides, log 2 n plus 1, log 2 of 2 to the power of h, log 2 n plus 1. The log 2 of 2 to the power of h plus 1 is h plus 1. Then I will shift minus 1 here, and then h equals log 2 n plus 1 minus. This is the minimum height of an computed tree. Then if I want to take the maximum height, then n equals to h plus 1. Then keeping h here, if I move 1 here, then h equals to n minus 1. This is the maximum height can be computed. Types of binary trees. There are 4 types of binary trees, that is full, proper, strictly binary tree, complete binary tree, perfect binary tree, degenerated binary tree, balanced binary tree. This is the 5th one. Actually, we will take only these 4. Now we have included another one is balanced binary tree. I will explain one by one in upcoming sessions. Now let us concentrate on what is full or strict binary tree. The full binary tree is also known as strict binary tree. The tree can only considered as the full binary tree if each node must contains either 0 or 2 children. That means if a node is there, it should contains at a maximum 2 children, otherwise no children. It should have 0 or 2. Then we will call it is a full or strict binary tree. The full binary tree can also be defined as the tree in which each node must contains 2 children except the leaf nodes. Here I will going to an example. Now you can see here A is consisting of B and C, and if I take B, it consists of 2 D and E. Suppose you assume that if there is no C, then we won't call it is a strict binary tree, but it will become only binary tree. That means it should have 2 childrens or like this, no childrens. In the above tree, we can observe each node is either containing 0 or 2 children. Therefore, it is a full binary tree. What are the properties of full binary tree? The numbers of leaf node is equal to the number of internal node plus 1. In the above example, the number of internal node is 5. Therefore, the number of leaf node is equal to 6. Here I have explained how it is there. Sorry. The maximum number of nodes is the same as the number of nodes in the binary tree is 2 to the h power of 1 minus 1. This is the maximum height of the tree, and the minimum nodes of the full binary tree is 2 into the h minus 1. The minimum height of the binary tree is, previously I have shown how we have calculated log 2 n plus 1 minus 1. The maximum of the height of the binary tree is computed as this is also shown here, n equals to 2 to the 2 into h minus 1. Now what I will do, I will shift 1 here, therefore n plus 1 equals to 2 into the power of h. Now I want the h. If I keep h here, h equals to the n plus 1 whole divided by the 2. This is the maximum height of the binary, that is complete binary. Thank you.